I don't have Slack up right now anyways. That's okay. Cool. Should be live. Yep. So let's go ahead and work through this. You're talking about the get all odd numbers. So first, let's read through the problem. So who was able to finish this one? Who successfully finished this assignment? All right, we got a few people. That's good. There's some gotchas around it that are sort of the tricky parts, and you need to think of the different aspects of it when you're working through it. So the first bit, the instructions, right? Write a function called get all odd numbers. All right, well, we already have that function. It will take an array of numbers as an argument and return a new array that contains only the odd numbers from the original array. The original array must not be modified. So then there's an example here. Oh, I didn't actually share my screen with the projector, silly me. All right. And then I also mentioned, remember you can call a function inside another function, and you already created the function isOdd in another assignment. If you copy that function to this one, then what's going on? Did it turn off? Yeah, we'll see. Might be too hot for the projector.
Sitting there a minute ago.
I know. I think it just turned off because I didn't connect early enough. But so let's go ahead and, for the sake of sort of solving it that way, let's recreate this isOdd function that we had before. So this will take a number. Let's just say num. What we want this to do is return true or false based on whether or not that number is an odd number, right? I cannot tell if this projector is on. All right, it's just still warming up. So, well, you guys can't see my screen. It's a challenge. How did anybody want to talk about how they solved the isOdd or wrote the isOdd function? So this is the one that takes just one number and returns true or false based on whether that or not that number is odd. No takers? I'm talking about their solution to that so we can use their version of that function. Yeah?
If number in percent to equal to 0, return false, else return true.
I'm going to be even lazier. I didn't even do the else, because if it's even right here, it'll return false, and then I can just say return true because that happens to be every other case. Great, so now we have an isOdd function that we can pass numbers into. So now we've got our get all odd numbers. Now what we know we want to do is pass in an array of numbers to this of some kind. So let's start with that. And then we want to iterate over them. So I'll start with a while loop because it's the one we're most familiar with, and I'm going to show you guys a few different ways that you could write this as well. Is this large enough for you to see? By the way, I can make it a little larger. So if this is going to take an array, and we're familiar with how to do an array while loop or iterating over it, right? So let's sort of stub that out. I'll say iterate over the array of numbers. And this is this idea of as I was calling it before, like comment-driven development, right? Write out the comment to say what you're going to do, just to help you think about it in plain English before you start writing the code, because that's helpful to remove the idea of what you're trying to write from having to deal with the syntax of it. You're only dealing with one thing at a time then. So I want to iterate over the array of numbers. And then for each number in the array, check if it is odd. If it is, then put it into a new, I won't say new, an array of odd numbers. And after we've done all that, we want to return our array of odd numbers. Does that make sense from a logical standpoint, or would anybody think about like writing out some different steps, doing it differently? So then I'm going to start implementing some of this, right? So we know how to set this up. We need an index, and we'll start it at 0. And then while index is less than numbers.length, portion you guys should all be really comfortable with at this point, as we've written this quite a bit, right? So, okay, and then we need to make sure that we increment our index each time we go through this loop so that we're changing our value. So that's sort of iterating over the array of numbers. And this logic we want to do inside of this array. So I'll just move this stuff up just as a placeholder up in here. Thinking about it. And then we want to return our array of odd numbers out here. So before we solve this little bit, this inside of here, let's think, okay, how can we return our array of odd numbers? Return, we haven't created one yet. Yeah?
So you need to call odd numbers first, like on the top? Like
we do. I'm thinking of it, what I'm getting at is you don't have to necessarily write your code linearly. Like you don't have to write it, this piece, this piece, this piece. Sometimes you can write the simple pieces and get those out of the way, and then come back and think about the complex piece later. So like a simple piece is, we know how to return a value. So that's not too bad. So let's right up at the top here. All right, well, we need a value to return, right? So let's call it like odds.
So as long as you call it before you return it, then it doesn't matter what you put it.
Yeah, in some respects. But yeah, I mean the key here is to learn how to decouple your thinking from the order of the code necessarily. And sometimes it's easier, especially when you're working on a problem, to do like the really simple parts and to just say this complex part is going to be done somewhere else and I'm not worried about it right now. And that's a little bit of what I'm doing in this while loop. Like I set up the syntax of looping, but I'm saying like, I don't yet know how to solve this adding things to the array or any of that, right? What I do know is I know how to create an empty array, and I know how to return a value from a function, and I know how to iterate over an array. So I'm starting with like the simple pieces that I already know how to do, and just sort of putting these comments in place of saying, I'm gonna do something here and I don't know what it is yet, right? And that can help you out a lot when you're working on any piece of code, is build out these little simple bits and sometimes just mask the complex thing entirely. Like act like it's just going to work. And that'll make a lot more sense as you think about stuff from a functional standpoint. Because for example, let's say we didn't implement this is-odd at all, right? Let's say this is hard. And maybe I'll give an example, you know, in just a little while of one that would be very hard to try and implement. And you may not even have to know how that works. or even think about it at the same time that you're trying to think about how to step over the arrays, right? Like stepping over an array, creating a new array, all of that. Well, that's sort of one thing that you're trying to do. You're trying to walk through an array. You're trying to create a new array of some kind using some values. That really isn't coupled in any sense to the idea of what you're trying to do to determine how to put something in that new array. And so by composing these functions and using them separately, you don't have to think about all of the problems that you're trying to solve at once. You can think about them piece by piece. Yes?
A good question. I see in the first function that you have the first if statement, and then after the if statement block, you have the result true. In this case, you don't have to use else. The language will assume that the else automatically will.
No, it doesn't assume that the else is there. What I'm doing, you could use else if you wanted to. Like an else will always run if nothing in an if or if else block. If none of the other cases match, an else will run. But what I did here was simplify it, because if we think about the two possible cases that we have, if it's, we can walk through it thinking about it from, let's try it with like 1 and 2, right? Is, very, very light red dot, and we can even see it. If you have like 1, so 1 mod 2 is 1, so it's not 0.
Okay.
So it doesn't get handled by this if block, which means it'll automatically go to the next return, or just keep running the code in the function, which returns true. But if it's 2, it'll get handled by that if block. So you can be, in this case, you can be a little lazy. You don't have to put it in an else, because that other return is going to run if you didn't return false already. It's sort of an implicit else, but the language isn't doing it for us. We're just being lazy and saying, I don't have to write the else stuff around it. I know there's nothing else that I want to do. All right, so we sort of dealt with the simple pieces now, right? The pieces that we feel comfortable with from code that we've written other times. We can return a value. We can create an empty array. We can iterate over it. Now let's get into the complex part. Yes?
One thing about the empty array, why does it make a difference if you call the empty array above the get all odd numbers function?
What do you mean? If
So when I wrote the code and submitted, I declared the odd array, the empty array,
yes.
outside the function, get all odd numbers,
Mm-hmm.
and it wouldn't, and it was saying it was incorrect. And then I moved it inside the function.
Oh, okay. I got you. Well, let's take a look at that after we do this solution, and we'll move it out and we'll see what happens. It may or may not be the exact same case as you, but we'll see. We'll see what the result is. All right, so now we got this bit, right? Well, we know what number we're on. We know how to iterate over an array with this index. We've been doing that. So that shouldn't be too hard. And we even wrote this nice isodd function up here that we can use. So for each number in the array, check if it is odd. All right. Seems like something we can probably build. How would we check the current item in the array? Each time we go through to check if it's odd? Feel free to take a guess.
Do we call something like this if it's odd? So you,
Right. So how do we get the item in the array as we're iterating through this loop? How do we check? How do we get the value at the current index or whatever?
It would be like odds, the variable odds with the indexing inside.
The index. We know how to get like numbers index, right?
Yes.
That'll give us the current item. And how can we check if that is an odd number?
If it's equal to is odd,
Numbers only.
You send it into the isodd.
You send it into the isodd function. There we go. So what we'll do is we'll call is odd. passing this number in to it. And if it's a little complex because I put a lot of stuff on the same line here, we can break that down a little bit if we prefer, right? We could do like var current num equals numbers index. So we're holding that current value, right? This way we're breaking it down so you don't have to try and think of everything all in one place. And then we could do check if is odd current num, right? So if the current number is odd. All right, so if that's true, what do we want to do with it? I've already heard this one, right? So we want to push it to our odds array, right? We want to push the current number into it.
What about the index?
What about it?
So you did it. Never mind.
Yeah, I'll whiteboard this out so that I think it'll make more sense. I think I get where some of the confusion's coming from now. So if we push it into our new array of odd numbers, all right? And do we need to do anything if it's not odd? No, other than increasing our index, right? We just skip over it. So let's go ahead and let's run this with some of our own test data and see what happens, right? 1, 2, 3, 4, 5, 6, 7. Console.log. Get all odd numbers. We call this with nums. And let's see what happens. So we get back from it an array of just these odd numbers. But let's also check real fast. Let's make sure that we didn't modify our numbers array, right? Because I'm sure that's also a mistake that was made on this one, is people were changing the original array as they stepped through. All right, the original array looks like it wasn't changed. So let's run a quick test and see if we pass. Awesome, it looks like that accomplished what we were trying to get done. Any questions about that so far? Does it make sense? Yeah? All right, so let's start looking at some of these variations that people had, and maybe people can even, we'll look at moving this odds out and see what happens, but maybe we'll even talk about some of the other variations that people had that weren't working, and we might be able to talk about why they weren't working. So what you're saying is you did something like this, right, where the odds array was defined up here. And let's go ahead and run this down here, and it looks like everything's correct. Because we get an array of just odd numbers, and we get this other item. But then when you run the tests, you're saying it doesn't pass, right? So what's going on here and why that's causing an error, and it's sort of a coincidence that that an error occurred here. I'm glad it did, but it wasn't like what I was intending. I'll bet you had some test data down here just like this in your code to check and see what was going on, right? And so what's happened is you've run through this once, as you just saw in this test case, where it says expected 1, 3, 5, 7, 97, 521, etc., to equal 97, 521, 351, etc., right? Well, it looks like this is the result of my test, and then the rest of it matches correctly. And that's because it's not going to redefine this array again. And since there's like test code down here that's already put stuff in that array, when this function runs through, it's going to just keep working with that same array object and adding new items to it, and it won't match what was expected. And that's one of the dangers of working with a variable that is a reference like this that you're not creating inside of your function or returning from it. I'm not saying that you never want to do that. There are definitely times where that's the intention, where you're trying to modify something. But that's one of the dangers that can happen is multiple things modify it and you don't really realize, oh, this is making changes to something external that can also be changed by something else. And that's the reason that it doesn't actually match the results I wanted. And that's why, just from experience in programming, I know that in this case, it's a lot safer for me to declare this array inside of my function, because now there's no way that anything outside of this function until it returns the array could possibly have an impact on the values, right? Once it's returned, obviously I can make changes to it again, right? Like at this point, if I assign this to a variable now, odd nums, get all odd numbers, nums, and I log this, and then I make a change to it. Let's do like odd nums dot push 57, and then let's log this again, just so.
When you say push 57, you're putting 57 into the array.
I'm pushing 57 into the array, and so what you see is, all right, 1, 3, 5, 7, and then I push it into the array. We added 57, so it's on there, right? So once you've got back a reference to that object, in this case an array object, yeah, now I can make changes to it outside of that function still. But the safeguard here was by creating it originally inside of the function, nothing else could have given me something with data that was different other than what I expect, which is a nice clean array. Anybody have any other routes that they tried to take that didn't work? Any other problems that people encountered? I'm happy to talk to them because, I mean, it's a good example of a lot of different aspects of coding here. Go back up here and have all of this on the page so we can see it all. And then once you sort of have your code in place, you can delete your comments if you want, because you're like, oh, I don't need to have these comment placeholders telling me what I'm doing. The code is pretty self-explanatory as to what it's doing at this point. So let's just get rid of all that and let the code speak for itself. Sometimes you want comments in code. Usually you leave comments in your code after you've written it when the code is doing something tricky. Like this might be a great example for something that would be tricky for a new programmer. So maybe we put a comment up here in this is odd that says, using the modulus operator to get the remainder from division by 2. Odd numbers will have a remainder of 1. Even numbers 0, right? Like maybe it's worth putting a comment up there at that point because it's something you guys are new to, and I want a reminder of what's going on here. There's a little bit of tricky code. I can't understand it just by a glance. And also, when you're reading code or you're trying to understand it, a really good thing to do while you're trying to understand it is do exactly this. Like you're stepping through it, you don't quite understand it. If you read a line and suddenly, okay, I know what's going on, put a plain English description there of what's going on. So the next time you look at that code, you can both look at the code, go, oh, wait, I can't remember what it was. Here's my plain English explanation. Okay, now I can make this mapping, and it helps reinforce it in your brain. Were there any other ways that, any other things that people encountered that they wanted to talk about on this one? Was anybody accidentally, yeah?
It's not about this one, but I remember when you were doing what I wanted to have it for in a condition, not a condition, but when you put else, you put return and you like made it say error.
Yeah.
Making it a string.
I returned an error of some kind. Yeah, that's, I mean, it's probably not something you guys need to deal with too much right now. But you could, like here, what would happen? Let me test something real fast. Okay. You could, like, do error statements. Error statements can go in your code, and they're really useful when something's happening that you didn't expect. So let's say in this case, or let's just put one here at the very beginning. Now I guess I don't know if it'll even work here. We'll see. We're gonna see how this goes. I'll say if num mod 2 I'm going to call, I believe this exists. So we're going to see if this is real. I could be wrong. But I'm checking to see if this is not a number. So I think this number object, and remember we touched on this just briefly at the end of last class, there's objects that map back to these built-in types that give us some methods that let us do some powerful things. So I think number object has is not a number. If not, I'll check the documentation in a minute and make sure. But then you can throw an error. I think it's uppercase. If like you passed in an argument that wasn't a number. So let's try this out. Let's right here we'll call is odd with hello. Again, I don't know for certain if this is going to work the way I want it to. But we'll find out. There we go. And we see my error got thrown. That's error handling is a little tricky to introduce. It's a tricky concept for new developers to understand because it sort of bypasses all the other rules. Like we've talked about program flow. Your program's running and then it calls a function and it jumps over there and runs. And then when that returns, it comes back and continues running the code that it called from, right? Error handling bypasses a lot of that in the sense that there's, and it makes sense, an idea that when there's a real error in your program, you shouldn't keep running because stuff could get worse, right? You could make other things worse, or there's no point in continuing to run because there's no logic in anything going on with whether hello is odd or not. And so throwing an error sort of circumvents most of the standard flow of the language. It just skips right out of wherever you're at, jumps up to higher levels, and gives you that error message. You can do sort of a secondary path of logic to handle error messages in your code if you want to, but it's not something that you probably need to know when you're first learning. It's something that's better to introduce after you've gotten comfortable with programming outside of that model. That's what you're referring to? Yeah. I mean, it's very powerful and it's useful and something, if you're having problems, you might try it out because it lets you, it's another way to log information. But like I say, not something that you necessarily need to do all the time. It doesn't work. All right, it's annoying. So any other questions about what we've done so far? No? So I think this will be a great time to kind of get rid of my error handling just so that our code is more concise. I think this is a great time to show different ways that we could write this same code. And some of these are things that I haven't introduced, but I definitely encourage you when you're learning to program right now, go read other resources, go check out other stuff because there's other ways to handle some of this. So a very common other way to loop, what probably one of the most common across all programming languages, but I didn't introduce it at first because it sort of puts a lot of bits together in a carefully constructed way. A while loop is very simple, is what's known as a for loop. And the difference between a while loop and a for loop is a for loop puts, remember when we were setting up a loop, we needed some sort of variable that we were initializing, right, for this index. All right, so let's do that right here. Var index equals 0. We're just sort of putting all of our code in one line here. And then the next thing that we needed was some sort of comparison, right? So I just put a semicolon here. Remember, a semicolon is how you say a statement is done in JavaScript. So we've created our index. The next thing that we need for any loop, and it exists in a for loop, is the comparison. So index is less than numbers.length. And then what's the last thing that we need in any loop to make sure that we eventually exit our loop?
Index plus plus.
You need to change your condition, right? You need to change what you're checking somehow so that you'll exit that loop eventually. And in this case, the way that we change that is by incrementing our index so that this condition is changing each time, right? It's a different comparison. So you can move that up here too. And now we've written the same thing, but we're using a different looping structure called a for loop. And really all this did for us was it let us put all of that loop logic in this one place, so we didn't have it scattered about in our code. We didn't have some initialization up here, and then a check, and then incrementing the value down below. It's all in one line. And that works exactly the same as the while loop.
It's easier that way.
What?
It's easier that way.
It's a lot easier once you're comfortable with it, because you get to think about those pieces of the looping logic. Remember, just what I was going back to before, right? You want to break down your code into different pieces and think about one piece at a time. And so this for loop lets you think about these pieces of looping logic, the initialization, the comparison, and changing your condition all at one time, and only when you're thinking about your loop. You don't have to remember, oh, I forgot to change my value later, right? It lets you think about this one piece in a very self-contained area. And that's probably why it's way more common than while loops and other things, because it helps you think about stuff a piece at a time. All of my looping logic, all in one place. So if you guys want to use that in any of your loops from now on, whenever you're writing anything, you can use a for loop. If there's any questions about it, I would recommend you just search up. I usually recommend when you're searching for JavaScript resources, use MDN, like for loop or something like that. MDN is the Mozilla Developer Network. They have the best documentation for JavaScript, so I like to use them more than anything else. And now here we are on their page, and what does it look like? Here's a for loop which says initialization, condition, final expression. So that's exactly what I was just saying is what we have whenever you do any loop. A for loop just puts all of it nice, self-contained right there. And then they'll have a lot of examples of how to do this. Any questions about that? All right, now we did introduce, just very briefly at the end of class last time, a new method that exists on arrays that lets you step over each item in an array. Does anybody remember what that was? That was called for each. And what for each will do, let's go ahead and search it up. Let's look at some documentation on it. I use this more than anything else because it lets me keep all my documentation in one nice simple place. But let's try and look at what for each does. Look at the for each method executes a provided function once for each array element. All right, that's a little confusing. I don't understand what that means. Well, here's a good example. A.for-each, an array of just these three items, and it has a function which takes the element, and then this one's just logging it, and what you'll see is A, B, and C. So essentially what you do is you declare a function that will take these items, the for each method will then call that function with each one of those values and perform whatever, you know, action is in that function. That's really cool. You can also, you know, it says the element, but it also actually takes, this is the element or the current value, but you could also pass in the index and the full array if you need to do extra work or that stuff matters. So let's go back to this, and this is going to be something that's more complex again, but let's try and rewrite this. So instead of using a for loop, we still know that we want to have an array returned with the odd numbers, so this logic seems like it needs to still stay. But for that logic of iterate over each item for each number, we can do something different. We can do numbers dot for each. And this is going to take a function which will get the current number passed into it. I'm writing some stuff sort of in line here. We can break this out more if it'll be easier for you. But this is very much the same type of logic that we had inside of our loop before. So what actions did we take inside of our loop to check and see if we wanted to add something to the new array? What were we doing before to check if a number should go into the odds array? If is odd, and we were checking the number, right? Well, in this case, this for each is going to call this function and with each number. So it sort of passes it in here. All right, and what did we do if it was odd? Push. Odds dot push the number, right? Okay, so let's see what happens here. That did the exact same thing. And if we run our tests, we see that we pass. But we were just able to accomplish the same thing yet another way, right? There's a lot of ways to solve the same type of problem when you're doing programming. This is a powerful method that you can use. Probably using for loops is better at first, so you get comfortable with what's going on. But this is the idea of function composition, which lets you do some very powerful things. Now let's do something. Let's try and create this for each loop ourselves. Let's say we were trying to do that instead. So function for each. Or let's even do it this way. We've worked with objects just a little bit now, so let's just go ahead and create an object. Var, heck, we have one down here. Var nums, right? So let's add this method to nums. Nums.forEach. We're going to add it ourselves. Now you really shouldn't do this because we're going to cover up the existing for each method as a result of us creating our own, but let's try and do it. So for each is going to be a function on our array of numbers, and it's really a method. Okay? And what does the for each method up here take as its argument? Or what's its parameters? Yeah, this is a little tricky, but what's its argument?
Well, it's checking to see if the number is odd in an array.
Well, what is the for each, like, what is its argument? It takes a function. They call it a callback, right? For each expects a callback or a function. Just like in what's the argument or what parameters, is odd has num as a parameter, but it expects a number, right? For its argument. For each expects a function for its argument. So let's just call that fun. Or we can call it callback, as they had in their documentation. All right.
But then what you're doing here is the same thing as
It will be. We're going to build it out. I mean, this is pushing you guys a fair bit. But yeah, let's talk about it, you know, engage. So how do we iterate over an array?
Stop length.
All right, we've done this a lot, right? How do we iterate over an array?
we're not using the same arrays that we have.
How do we iterate over any array, right?
Bar number, stuff like that.
Or index.
Right, we have an index. Let's do it with the for loop so that we're just doing one other thing new. So for var index equals 0. And then what do we check? We check if our index is less than
No, stop.
nums.length. That's good, except remember how do you refer to the object that you're inside of when you're in it? Does anybody remember? This. So this dot length. So that will work on that will refer to the object internally without having to use its external name of nums. And then what do we do? Inside of a loop is our last step. Change the condition. There we go. So we've got a loop. We've for each here. Now, what do we want to do inside of this loop?
So if
No, we're not trying to solve the problem. What we want to do is allow the function that we passed in to get called. We want to model what this does, but not what this does. We don't, this is the internal function being called. We're just trying to model this for each portion. So what did we do before with, say, our is odd? Like we got our current number, right? Let's do that. So this at index, right? That's the number that we're currently on. We're stepping through. And then how did this callback work? This function got called with whatever the current value was for each item in the array, right? So we can do that, except in this case, it's called callback. So callback with the number. And what we want to do is, I don't know, let's check what the return value is from this for each. What does it return? Undefined, so it doesn't return anything. It just calls the function and doesn't return anything. So there we go, we're calling whatever function we passed in for each number as we step through, one at a time. And we've now essentially re-implemented this for each on our array. So let's see if this is correct. Let's see if it works. We'll run it. And see something a little interesting, right? Like, sure enough, we did work. 1, 3, 5, 7. It looks like it worked correctly. And then when we logged the original nums object, we see all of our items plus this for each function. So maybe it didn't work. Let's test it. Let's just see if we did work by saying, all right, when this is called, let's console.log something so that we know we worked. Calling R for each. I don't know if this is going to work or not. We'll see. Awesome. So we called our version of the for each method instead of the one that was built in. And then we can even run our tests and see that, sure enough, those tests run the same. So you can see that this little for each that we had here that we switched over to using, it's nothing magical. It's just a way to sort of encapsulate all of that iteration logic so that you don't have to think about it every time you're doing it. The tricky part about it is the concept of passing a function in and having it work with these values. There's some tricky aspects to that you're getting used to in your mind, but there's no magic behind what happened there. Any questions about that? You don't get the call back? Let me mull that over a little bit. I'll try and get through some of our material for today, and then I'll try and come back to it, and I'll see if I can call back to it with a better explanation than I have right now. Because it is a challenging idea. But I think I'll be able to come up with something. All right. So if there's no other questions about that right now, other than the callback bit, which we will come back to, then let's go ahead and we'll go over objects a little more today. A lot of this is going to be review again, and then I want to talk about, at least conceptually, the idea of composing objects or object relationships. So quick review first. We've talked about recursion. I can't even hide it. Oh no, the text is, let's make it really large so you guys can't see the answer real fast. Does anybody remember what recursion is? A function that calls itself. That's really all recursion is a function that calls itself. Can anyone explain some of the values of using recursive functions? What does it provide? Does it do anything? Is it, let me ask this, is it more efficient for the computer to use a recursive function or less efficient? It depends. Usually it's less efficient than if you wrote something out iteratively, because function calls, can be heavy. So then if it's not particularly useful for the computer, is it useful for anything else? I mean, potentially, usually not. I would say that the biggest benefit of recursion is not in, recognize that the vast majority of things that we've created in programming, objects, arrays, all of these, they don't exist to make the computer work faster with the data. They exist to make it easier for us to work with it. And that's what recursion is too. Recursion is a way for us to think about stuff that might be really complicated to write out iteratively in a recursive way and break it down. It's yet another way to break down problems into smaller pieces as you work with them. And it's something that at first you're like, no, it's not easier, it's much harder. It's way harder to think about something recursively, but after you've worked with code long enough, you begin to realize that there are a lot of cases where it does help you think about problems in a much simpler way, much simpler mindset. And then what about objects and object-oriented programming? Can anyone describe what an object is?
Object is anything you can describe.
Yeah, I mean it's a little hard to describe, right? It feels you use sort of loose words, but it's just an entity that has properties in JavaScript. You might see it described in a lot of other languages as an entity that has properties and methods. And an object just encapsulates state and function in its properties. State being things like name and age and location, and function being things that they can do, run, you know, say hello. So that's, I mean, it's just a really quick overview. For the rest of today, I think the first thing I want to do is go over creating objects in JavaScript. There's a lot of different ways to create objects in JavaScript. Some of the languages, if anyone's familiar with them, there's like, here's the one way to create objects in another language. JavaScript doesn't operate that way. JavaScript has a lot of different ways, and so I want to touch on each one of them briefly, or maybe not all of them, but a large number of them today, so that if you encounter these different ways to create objects, you have some familiarity with them, and that you realize that there are pros and cons to different approaches when you're creating objects. And then we're going to talk more about inheritance and object relationships and how you can build something much more complex. So you guys should feel pretty comfortable with the object literal syntax after the last couple of classes. Can anyone, maybe you don't know the exact words, but what's the object literal syntax way to create an object?
Isn't it the same thing that we did with Chair where you went and created properties of it?
Yeah, it's just, I mean, all it is you're just creating an object. They call it literal because you're sort of literally describing it, right? You use these curly braces. You just assign it to something like we're doing here, and you've got this sort of object literal syntax. So in this case, it's very simple. Var person equals curly braces, and the most basic would be curly braces with nothing in it, but you can also set some properties while you do it. Right? And then you close it like that, and then you have an object. So this is pretty much the only way that we've really created them so far. Like I said, you could create one, again, var person2, and they don't even have to have properties right away. You can do it just with these curly braces, a lot like an empty array. And then you have sort of an empty object. It doesn't have any properties directly on it. Any questions about that? So let's say we want to create a bunch of different people, and we want them to have the same properties each time. We want them to have a name and an age, and maybe we even add a few other ones in. We say the state that they live in, and the number of siblings that they have, and I don't know how tall they are. Can you see any issues that you would have if you were trying to create a bunch of people using this object literal syntax?
You have to put in each variable.
You have to put in each variable, and you have to create a new object each time using this syntax over and over, right? Yes?
You mean like how we replicate? No.
Yeah, how would you, are there any challenges with doing that? If you're just trying to create a bunch of them, right?
Do we call it like call it? In this case, I mean, create a template.
See, you're already stepping ahead, right? Yeah, like you're going, man, I don't want to have to write this object literal syntax out for each person. That's a lot of extra typing, and it's very error prone because I may go person2 dot right, and then I'm trying to get the name off of person2, and it's undefined, and I'm like, what do you mean it's undefined? I don't understand what's going on. It's because I typed it wrong one time. And it's very hard to do if I want a program to create all of these. I can't do it very effectively this way, right? So there's some cons to this sort of object literal way of creating people. And one way that you could work around that would be something like an object factory function. So this is another pattern that's very common in JavaScript. It doesn't exist in some other object-oriented languages, but very common in JavaScript. You need power. She opened up the power well underneath earlier, and I know this because I heard it downstairs, and I was like, "What is that noise up there?" And then I realized it was that being open. So an object factory function is just, it's very similar to object literal syntax, but the object creation is wrapped inside a function call, so multiple objects with the same properties can easily be created. So if we were to create a function like that created a person with these two properties, function person factory, let's call it, what would we need to take in as, what our parameters need to be? We want to be able to create people that have a name and an age. What do we need for parameters to our function?
So person dot name.
We need a name and we need a what?
Name and
Age, right? Because we want to set those. Okay. Now, how did we create an object before using object literal syntax? Let's create a very simple one here. Let's just do var person. Let's make it one without anything on it. Now, how do we add properties to this? We do if you want to add a property to an existing object, how do you do that?
dot push.
So dot, it's not push in this case. For a property on an object, it's just dot, and then we want it to have a name property, right? So name, and what do we want the value of that to be? Well, we want it to be something that was passed into this function, right? Well, we want it to be the name that was passed in. All right. And then we also want this person to have what other property? An age. What's its value going to be? The age that was passed in. All right. And then I assume, given this is a function factory, whoever called it, we want to give them back the object. So how can we do that? Return person. And now we have a simple factory that can create people objects that all will have the same properties on them, right? So we could do var Sarah equals person factory Sarah and 21, right? And we have a Sarah object. Then we can do var John equals person factory John, let's say he's 24. And we've got a John object, right? So that's using the same object literal creation method that we used before, except what we've done is wrap it inside of a function. And by doing that, we now know that every object created through that function call is going to have the same set of properties as any other object created through that function call. That's really nice. I think in the example here, I had only one real difference. I added an extra method on. Let me not call say hi. I'll get the rest of it first. So here, I just added an extra method that we created inside of our person factory called say hi that would print out their name and age or whatever. And now, since we have a John, then we can do John.say hi. And he'll go ahead and print out the information for him. Or Sarah.say hi. And she does the same thing. Does that make sense? How we can do that and how we can get objects that all have the same properties very easily using this sort of factory? So that's a very common pattern in like JavaScript, for example. You can create an object this way. And now, you know, if we wanted to add new properties to these, we wanted to create people with new properties, well, we can just create a new person factory that takes in new arguments and assigns new values off of those, and we can create a person that way. And no matter how many people we create, they're all going to have those same set of properties, those same methods. Everything will be consistent between them. Any questions so far? And feel free to speak up if there are. So now we'll get into another way to do that, and this is going to be similar to this factory, but different. So this is an object constructor in JavaScript with the new operator. So in JavaScript, this is different than people who are familiar with other programming languages. A constructor is just a function that happens to be called with the new operator. So we've already created a whole bunch of functions. The difference here is that a constructor is the same as any other function, except it's called with the new operator. They behave very similarly. I think that I'm missing stuff there. That word is not right. To an object factory. But they don't require creating an object literal and returning it. They work a little bit differently. They're sort of a combination of the, how did we reference properties on an object from methods inside of it? Do you remember how we did that? If we want to read the age off of a person for a method inside of this part of that object? Or when we were writing the for each, how did we refer to the array? You use this, right? We have it like right up here, this. Oops. That's the same approach used with the object constructor. So what we'll see here is we've got a person object constructor that's very, very similar to what we just wrote with our factory, except we've got a few key differences. A, we're not returning anything at the end here. We're not returning our object. And I'm actually going to scroll this up so you guys aren't looking at it being called so much. And B, instead of creating an object and then adding properties to them that way, what we did was we just referred to it using, gotta learn to not double click, using the this syntax. This dot name equals name, this dot age equals age, and this dot say hi equals this function. And then when you have a function that's sort of written this way, you can call it using this new operator, and it will return to you a new object with these properties. Oops, way too much code selected. So this is a little bit of a different syntax than you guys have really seen. I did introduce this, I believe, at the end of last class, but this is the traditional, I would say, way to create objects in JavaScript. The oldest method other than object literal syntax, but if you're trying to have some sort of object constructor type approach, this is the way you do it. You've got a function that can set these properties on it, and then when you use the new operator, you get back an object from that of that type. And we could call John.sayHi, and it's going to work the same as we did before. And are there any questions on this? There should be. This is very, very different, very weird, right? What? Right over your head? This is, so, I mean, you're thinking like, well, we've called functions before, but we never used this new. Like, what makes this one special? We're setting properties on it with this. And if it was me, I'm an inquisitive person, and I don't know what the answer to this is.
So are you using there because you find the object in the function saying this instead of doing the variable each time? You're telling me this is how you do the variable inside that?
Yeah, in a sense, yeah. That's what we're doing. But yeah, if it's me, I'm an inquisitive person, and I go, wait a minute. What makes this different than other functions? What happens if I call another function with this or new? Like, what happens if I called, like, I don't know, and I don't know what the answer is here, right? So let's say var num equals new math.random. What's going to happen? Oh, it's not a constructor. Okay. I didn't know what was going to happen there. You know, let's try another one. Let's try that factory function that we have. We still have a people factory in here, right? Var John equals new. Is it people factory? John and 24 or something? Like, well, maybe it wasn't. Is it person factory?
Person.
All right. So let's call it that way. Use the wrong name. I don't know what's going on now. What does John have? I don't even know what. I guess we'll get the result of anything returned from it too, and it'll assign that as your object. I don't know. What if we have? Do we have is odd in here? I don't think we do. Is odd? No. So let's just define it. Function is odd num. If num mod 2 equals 0, return false, return true. So what if we var foo equals new is odd 3? What does foo get? It's got some sort of weird is odd function object, right? I don't have the answers to necessarily all of this, but these are the questions that would pop up for me as I'm with this constructor function, right? Like the syntax is very, very different or very weird, especially to people who are familiar with constructors in other languages and classes and the way some of that stuff works. But it is pretty much the same as that object factory that we had up here. This person factory, we just didn't have to create our own object and return it. We were able to do it much more simply using this syntax and get back something that was usable. It's really cool. And we'll get into some of the benefits of this a lot more later today probably, and definitely in the next class. Oh, I needed a space there. Look now. No, it was good that I jumped over. Okay, so let's talk about at least one more way to create objects, and then I'll quickly just touch on another one that we're not really going to show for now so that we don't confuse people who are familiar with other stuff. Another way to create objects in JavaScript is using object.create. So this is just a method on the object, built-in object. So if you're trying to create a new object, this may not, I may have to, let me see, I may have to pass in something to base it off of. Var person equals object.create. Yeah, it's going to yell at me, and it's saying object prototype may only be an object or null. All right. So I need to fix my syntax here. We need to use an object for it to base our creation off of. So this is going to get pretty interesting. Person equals object.create. So now we have a person. It's an object with nothing on it, but we can add a name. And an age. Same as we did with anyone else. Any questions about this? I had a question, I'd say, why would you do this versus, it looks like this was the same as that object literal syntax. What benefit do you get from using this object.create approach as opposed to just object literal syntax like we were using earlier, right? This just added extra words because you even had to pass in an empty object here. Oh. We'll come back and show the big benefits of object.create, but object.create allows for the concept of inheritance and setting what in JavaScript is called the prototype. And we'll get into the benefits of that. We'll have a little bit of time to sort of show that off and then really dig into it a lot more in the next class. And then there's one other way to create objects in JavaScript. And this isn't really a way to create them, but it's a way to set up, this is a replacement for the constructor function. And that's known as the class keyword, where you can create a class, if you will, for people who are familiar with other programming languages in JavaScript. And then when you use that new keyword to create an object, it will use the class to generate your object. I'm not going to introduce it. I want to make you familiar with it so you can, if you encounter it in JavaScript, you know that it exists. You can go look up how to use this and how it works. But because it's so similar to these other object-oriented approaches, and those work a little different than JavaScript, I don't want to introduce it and have the confusion over how they're different right now. For anybody who is familiar with other languages, I'll be happy to sit down and talk about the differences between JavaScript and, say, Java, or JavaScript and C# or C++ and how they work. But I think that's better for somebody who already has that familiarity versus trying to introduce it to you guys right now. Just know that it does exist. And if you encounter it, you can go read up on how to create objects that way. So now let's step outside of code for just a little while, and let's talk about object relationships. So this starts to get into the idea of, I said we're learning object-oriented programming. And so far, pretty much all we've talked about are an object. I can shut the door if you want. So far, what we've talked about is an object or creating some objects. But what's this oriented part, and how do these objects relate? How do we interact and work with them in these larger contexts? What's the value of really doing this? And the value is it lets us do a lot of much more complex programs while thinking of things in these self-contained encapsulated pieces. A lot like how the for loop let us think about all the looping bit without having to think about the logic inside. Or a function lets us isolate the logic for that piece of code. Working with objects, we've got multiple ways to put them together to build something more complex than what we started with. So let's say we have, let's talk about object composition. This shouldn't be a surprise. Let's go with a car, right? So if we had a car object, what are some of the properties of a car? Color, model, year, make. All right. What was that? Price. Now let's ask a question. What are some of the things a car is, what are some of the parts of a car? Right? All right, so let's pause for a second. These items like price, condition, make, year, model, color, those seem like pretty simple things to have, right? Like color would probably be a string if we were setting properties, right? Model, what do we think? String? Year, number, make, condition? Yeah? Okay, yeah. Thanks for coming for the time you were able to. Price? Number, right? What about engine?
Possibly number, part number, or string.
You could, But an engine is a pretty complex thing itself, right? There's a lot going on inside of the engine. Yeah, right? So if we're composing a car is composed of these other objects as well. And those objects have their own properties, but the car maybe doesn't need to know about all the bits and pieces of that other object all the time. Yes?
We can think out an number in string, so it won't be necessary to, have two types of.
Yeah, it doesn't have to be a number. It could be a string for price and year and stuff. Or you could have them be numbers if you want to do computations with them easily. But yeah, if we're talking about like the engine, that's something complex. So what are properties of an engine? Like what? Displacement. Horsepower. What are some of the other pieces of an engine? Pistons.
Cylinder head, intake, motor mount, tire pipe, distributor, valve cover,
And gasket,
Google.
It's a timing belt, right?
spark plug.
Without getting around.
No, it's great. I love it. Right? Google, yes. Let's take a moment and share something funny. Let's have some fun for a minute, right? Funny. All right. A pretty funny list of parody programming book covers, just so you guys feel like, okay, this isn't unique to us. Cutting corner to meet arbitrary management deadlines, essential copying and pasting from Stack Overflow. The passionate functional microservice, expert resume-driven development. Blaming the user. Googling the error message. The internet will make these bad words go away. Useless whiteboard interviews. Writing code that nobody else can read. Temporary workarounds. Expert, trying stuff until it works. Rewriting your front end every 6 weeks. Taking on needless dependencies. Excuses for not writing unit tests. So yeah, that's fun, right? Just so you get to feel. Programmers can make fun of themselves, and we do plenty of Googling to solve our problems. Googling for Stack Overflow answers is a very, very common way to solve your issue. So there we go. We've got some properties of an engine, right? And some of these look like they could be basic properties, horsepower maybe, or displacement. But again, some of these, pistons, cylinder heads, those sound more like objects. So we're starting to compose a very complex item here. What about a tire? What are some properties of a tire? Oh yeah. So what about some other parts? What are parts of a tire? The rim. Oh, brand is a good property, I'd say. Size. You might have the like, I don't know what else to say. Let's see. The valve.
Not only that, but like the miles, the warranty, how long is this last?
Warranty. It's a good property of a tire. right? So even with tires, we were able to, and you might notice I'm doing a little bit of a syntax thing here where things that I feel are proper object-like, I'm uppercasing, and things that I feel are more basic properties, I'm sort of putting as lowercase. So like tread, size, pressure, width. Those seem like you could probably describe those with just strings or some other simple value. But rim, that's probably something that's pretty complex. So it makes sense that that might be an object itself. And the valve, well, that might be an object with a whole bunch of other properties on it, right? So I hope this is giving a good feel for the value of object composition. Using this, we're able to put together, I mean, this is imperfect right now, but a pretty decent model of a car. And we did it without the car having to have each one of these properties itself. We could create an entirely separate tire object. And that tire object can have all of this. And then what the car can actually have is just an array of tire objects. And it'll be able to have these 4 objects that way. And then the car can just have an engine, and this engine is where we put all of the object parts for the engine. And so we're able to compose a much more complex object out of smaller, simpler pieces. Does that make sense? Good? This is the one that I want to emphasize much more. You're going to encounter, as you read about programming, especially the beginning of object-oriented programming, you're going to see a lot of stuff that talks about this next one that I'm discussing, this inheritance model for objects. Inheritance is important, but it's also sort of a dangerous path for reasons that you won't understand at first when you get into programming. So think a lot about how you can compose an object of other objects, object composition as the preferred way to build complex objects and work with things. So the next thing I want to touch on, and then, like I said, I might be able to come back around to talk about some of this other stuff, is let's talk about object inheritance, because this is really what a lot of people think of as the core of object-oriented programming. I think there's a lot more to it. There's a lot of aspects, but a lot of people think of inheritance as the core. So let's go back to our car. And our car has these different, I'm going to simplify it now so we don't have to worry about what's going on inside of our tires or our engine. But now let's say we have a truck object, right? What are some properties of a truck object? The same? Yeah, at least so far I don't see anything different, right? So let's go ahead and just cut and paste these down in here. All right? Are there any other properties of a truck object? Maybe some that are different between it and a car? Like a truck bed? Anything else? There we go, I like that. Something else, anything? What? The clearance, maybe, right? Oh yeah, yeah. I don't know how to even describe that, right? Drivetrain. I'm gonna make that an object, like that's complex. Yeah, we can add mileage to each one of these, right? And I like the idea of adding it in too, which we might come revisit. So we've got, okay, now let's start looking at these. What do these share in common? Like, as we said before, the vast majority of this is shared between the two, right? So would we say that like color and model and year and make, condition, price, mileage, you know, engine, tires, body, interior, are those really properties of a car, or are they of something more generic than a car? A vehicle? Awesome. So let's say we have a vehicle object, and these are really properties of this vehicle object. All right, so what is our Well, this is all the same, right? So what's different? Like, what does maybe a car have that's unique to a car? Has a trunk, maybe? I don't know. Yeah, and hatchbacks are way better. I have no opinion. Is hatchback? I don't know. Right? I mean, it could have different properties. So then, if we have this sort of common, all of this common properties, and yet there's something that's different between them, it makes sense that instead of having to define all these common properties on all these objects that are similar, maybe we can define all these common properties on some sort of object. So let me narrow this down a little bit, and we'll go to the whiteboard and I'll try and show it. And then these other objects can, in a sense, inherit or get those properties from that piece of common description, right? So this is commonly known as is-a relationship in object-oriented programming. So if we have, I'll put the vehicle over here. If you have a vehicle and it has, I'm not going to get all of these, but it has a make and a model and a price, and it has an engine and a body. Then you can create these other objects like a car and say that the car is a vehicle, but the car has some different properties as well. The car has a trunk and it has this is hatch like back property or whatever, right? And then we can also define something like a truck. And the truck is a vehicle. And it has some of its own properties that are unique to it. It has truck bed. And it has drivetrain. And it has towing capacity or whatever. So conceptually, there's two different terms that we use in object-oriented programming to talk about the way we put objects together. We have is-a, which maps to inheritance. And then we talked about composition before. Composition. So what might you say for a vehicle and the engine? What's that relationship? If a car is a vehicle, and that's the relationship between those, what's the relationship between the engine and a vehicle?
Is the car is a vehicle? Or one of the men?
It's not it is, because it's.
Right. It has an engine. So it's it has a relationship, right? So those are the two major, there's others, but those are the two major relationships that exist in object-oriented development. You have has-a type relationships. A vehicle has an engine, has a body. A truck has a truck bed, has a drivetrain. And then you have is-a type relationship. A car is a vehicle, and a truck is a vehicle. So conceptually, before we talk about what that means in programming at all, does that concept make sense?
Yeah.
Yeah? So what that begins to mean when we're talking about programming is, and object-oriented programming in particular, is you can, and objects can inherit from other objects. And it's a little dangerous to say inheritance, because the term doesn't mean the same thing as like I inherited my brown hair from my parents in a sense. Inheritance in object-oriented programming sort of means that what you've done is taken the set of common properties of an object, like these vehicle things are really part of a vehicle and not common to a car, and you've moved them into an object of a vehicle. And then when you create a car object, you will say that it, in JavaScript, it's called the prototype. The prototype of the car will be a vehicle. And by doing that, the car will inherit all of these vehicular properties and have access to those as well. But we didn't have to define them on the car, and we can share that set of vehicle type properties between multiple different objects. So this is a very powerful capability, because what you can do then is, again, it's about reuse. It's about composition. It's about being able to do stuff without having to redefine it in multiple places and share logic. You can move all this down into these base classes or base objects, and the higher level objects will inherit those properties, inherit that behavior from them.
So essentially you're saying that like, if you wanted to set properties for a four-door V6 vehicle, you could put that in an object or a prototype to inherit it when you select something, or call an object in the future.
Yeah, there's several different ways that this ends up shaking out, and so I don't want to. I'll show a little bit, but we're definitely not going to be able to cover everything in the time that we have today. But let's look at some basic examples. Let's do this vehicle right now, right? So let's create a vehicle object, and it will have these properties already on it. And this isn't the way that you would ideally necessarily do all of this, but let's do it this way right now. So let's just create a vehicle. And because you guys by now should be starting to get comfortable with like the object literal syntax, let's use one of our other syntax styles here. Let's use a constructor function. So function vehicle. And this guy's going to take some properties. We're not going to put everything. We'll do price, make, and model on it that we sort of pass in. All right, so does anybody remember when we're using a constructor function syntax, how we can set those on the object that we're going to get back? This is the way that you call it with new. Use this dot instead of, so this dot price equals equals the price. Yeah, we're not calling it yet. We're still creating the function. So then how do we set the make?
This dot
And let's go ahead and set some stuff that didn't even get passed in. We can set properties like that. So we can do this dot engine equals, and we'll just make it an empty object. This dot body equals like an empty object. All right. We've got a vehicle constructor function. Now, how can we create a vehicle using that? Var vehicle equals vehicle. All right. What should we do it for a price? Free.
Free.
0. All right. What's the make? What? 2017. Honda. I like Honda. We're getting a free Honda. What's our model? CRV. Action it, right? All right, so let's check this. Cool, we got a vehicle object. Awesome. Now let's say let's talk a little bit about this inheritance model. And this is one of the reasons I introduced object.create before, because it's one of the easier ways to do this. So let's say we want to create a truck, and we're going to do this sort of loosely. So do object.create, and then our base object, instead of being that empty object that we used last time we called this, we can use our vehicle. And what you'll see is something interesting. This truck, it doesn't say that it has any properties. All it has is it says it's like a vehicle. But what if we do truck.price? 0. And what if we do truck.model? What do we think that'll give us? What? CRV. But the truck itself, again, let's look at it. The truck is just this empty object. It doesn't have these properties on it because we didn't define any properties on our truck. So now let's add one. What's one of our truck properties? It has a towing capacity, right? Towing capacity. What should its towing capacity be? 20,000 pounds?
For a CRV. Try 3,000.
3,000? Oh, okay. Okay. Now let's look at our truck object again. Interesting. What we see here is it says we have a property on our truck now. It has a towing capacity of 3,000. But this bit here saying vehicle is saying its prototype is the vehicle that we already created and set using this object.create method. So this vehicle is our prototype. So now let's do something interesting. Let's change vehicle.price equals, what's a more appropriate price for the CRV? We realized we were silly. We shouldn't have tried to give this thing away. We need some money. 20,000. All right. So let's check what that's like on our vehicle. $20,000 Honda CRV, has an engine and a body. Now let's look at our truck. Still just a towing capacity, but what about our truck.price now? $20,000. And yet we didn't actually change anything on our truck object. Because in JavaScript, a prototype of any object is just another object down the chain. So each object can have these prototypes that just sort of move down this chain. What's going on in reality is we've created a truck, a concrete truck object that has real values here, like a real towing capacity. And he says, my prototype is this concrete vehicle, this actual vehicle with a price and a model and a make. And when we change the values on these, since that's the prototype of our truck, it reads the new values. And it's not reading off of this. In a sense, and I wish you've got your, I'm gonna go ahead and sketch it out over here, but so you've got a truck object in memory. And that has like this towing capacity value. I'll be a little lazy here. And it also has a reference to its prototype. And that's going to point to this vehicle object that we have that has a price that's now 20,000, and a model of CRV, etc. And so this just refers to this object. And when JavaScript goes to look for a property on our truck, for example, the price property, it's first going to check the truck object and say, do I have a price? Nope, no price. Okay, now look at my prototype and go check it and see if it has a price. And if that has a price, then print that as my price. And it's going to do that for any property that you work with on any object. And then if it didn't exist here, then whatever the prototype is of this, it'll go and check. And this can be chained pretty much infinitely, just down, down, down. But you can also override those values. So now we set 20,000 on our CRV for our price. But let's say that's not really a proper price for a truck. What's a good price for a truck? Brand new.
Probably about 35 for a base package.
35, all right. So now let's look at our truck object. Notice what's changed here is it's got a price on our truck object. So what's happened is we now added a price property right here of 35,000. So if we look at the price on our truck, truck.price, we get 35,000. And if we change the price of our CRV, this vehicle object that we have down there, and we'll say it didn't sell right away, so we had to drop the price a little bit. If we look at our truck.price, it didn't change the price of our truck at all, but our vehicle did. And that's because once we've set a price on our truck, it's now always going to look at this value first because it exists on the actual truck object and print that. When we change the price on the vehicle, we changed it over here, not on our truck object. And it's not going to get to that because it found a price and didn't have to go look in the prototype to try and find the price anymore. Because there's actually a price on our truck. Does that generally make sense? Yeah? And I mean, you can still get access to that as well. So 14 minutes remaining. All right, I'm gonna have to be done real soon. Is that dimming up there too? Not really, good. You can still get access to that off of the prototype. So off of the truck.prototype, I don't think you can access it that way, hold on. This is a little kludgy and I don't recommend you guys. .price. There's a couple underscores there. That's how you can access your prototype of something. So that told it, ignore the price on this, go right to my prototype and try and read the price off that. But that's sort of how you can compose this objects. That's the has-a type relationship, and we'll talk a lot more about the different ways to do some of that stuff. Or that's the is-a relationship, and then there's has-a, which is the composition. And that wouldn't work the same way, because if a truck has an engine, it can't go down through the prototype chain looking for stuff off of things that it has. You'd have to do like truck.engine. Looking for a property of some kind. There any questions on that as a high-level concept? I'm going to dive into keep talking about the inheritance, composition, and how that stuff works. Yes.
Would you want to make like the vehicle objects all blank, like the price and make the model blank, and then
Here, go ahead.
create the truck?
Oh no.
Is there a way to like?
I think I was recording myself.